In this video, I'm going to talk to you about the process of preparing solutions. This is a lab technique that you will need. It's also a type of quiz and test question that you'll encounter. Solutions can be made starting with a solid sample that you must dissolve, or you can start with an existing solution, add additional water to create a more dilute solution. If you're making a solution starting with a solid, you will need to dissolve a certain amount of the solid into the right amount of water to get a solution of the desired molarity. In this example, we want to finish with 250 milliliters of 0.75 molar copper 2 sulfate solution. How are we going to measure out our solid? In what unit and with what type of equipment do we measure solids in lab? We use an electronic balance to measure out a number of grams of solid. Well, how many grams of solid copper 2 sulfate do we need to make this solution? How do I figure that out? I use the molarity equation to calculate the number of moles of solid needed, then convert moles to grams using molar mass. Subbing the given numbers into the molarity equation and solving tells me I need 0.1875 moles of copper 2 sulfate. Since we can't measure moles in lab, we need grams, so I use the molar mass of the compound to convert moles to grams. To prepare 250 milliliters of a 0.75 molar copper 2 sulfate solution, you'll need 29.9 grams of the solid. So the first step towards making this solution would be to mass out the amount of solid specified by your calculation. The next step is not to measure out 250 milliliters of water and add the water and solid together. You want a solution with a total volume of 250 milliliters. But the solute is going to occupy some of that space in the solution. Less than 250 milliliters of water are needed to make 250 milliliters of solution. Instead, you need a piece of glassware called a volumetric flask. A volumetric flask has a wide, rounded bottom and a long, thin neck. There's a line etched into the neck. When filled to this mark, the volume of material is exactly the amount specified on the flask. A volumetric flask is used for that one specific volume only. This is different from a graduated cylinder, for example, where you can measure 22 milliliters, 37 milliliters, 41 milliliters, etc., all in the same cylinder. A volumetric flask only measures one specific volume of solution. The value of a volumetric flask is that the etched line is very exact, much more exact than the markings on a graduated cylinder or Erlenmeyer flask. To make solutions accurately, we always use a volumetric flask. To make your solution, add some distilled water to the correct size volumetric flask. Then add in the solid sample you masked. To ensure complete transfer of your solid, make sure and rinse the weighing vessel with some of the DI water and pour that into the flask as well. Stir or swirl until the solid is completely dissolved. Then carefully fill exactly to the mark with DI water, cap the flask, and thoroughly mix by inverting the flask several times. So to fully answer this kind of question on a quiz or a test, you have to do the calculations and you have to explain the process of creating the solution. For the question we looked at earlier, you would weigh out 29.9 grams of copper 2 sulfate, partially fill a 250 milliliter volumetric flask with DI water, pour in the masked solid. Remember to rinse your weighing vessel to ensure complete transfer. Swirl to completely dissolve the solid. Then fill to the mark with DI water, cap, and mix thoroughly. This question asks you to prepare a 0.125 molar solution from a 6 molar solution. This time we're starting with an already existing solution and we need to dilute it. We need to do a dilution calculation then. The question gives us the desired molarity and volume. We know the molarity of the stock solution that's available. We need to know what volume of the stock solution must be used and diluted with water to make the desired solution. Subbing in the given numbers and solving tells us that we need 5.21 milliliters of the stock solution. Like before, though, this doesn't answer the question. How do you actually prepare the solution? Like before, after completing the calculation, you have to explain the process of creating the solution. This time you're not massing a solid on a balance. Here, you need to measure out an exact amount of the more concentrated solution using a volumetric or a Mohr pipette. Like the volumetric flask, a volumetric pipette is volume specific. It has a single mark on the neck that very accurately indicates the amount of liquid contained. Another, slightly less accurate option is to use a Mohr pipette. A Mohr pipette is graduated, so a range of volumes can be transferred with this type of pipette. So to prepare a dilute solution from a more concentrated one, use a volumetric or Mohr pipette to accurately measure out the volume of solution determined in your calculation. Add this to the appropriately sized volumetric flask. Partially fill the flask with the DI water and swirl to mix. Then, just as before, fill to the mark with DI water, cap, and mix thoroughly by inverting several times. You can look at figure 4.6 in your textbook to review this process. This is an image from the ChemWiki website that reviews it for you as well. To summarize, when you need to prepare a solution in lab, or you're answering a how to prepare question on a quiz or a test, you should first determine if you're starting with a solid or a stock solution. Next, you need to do the appropriate calculation, either a molarity or a dilution calculation. And finally, make sure you know the process involved, including correct names for any glassware used.